Hello everyone, welcome to my channel. Today we are going to discuss about cryogenic temperature generation. But before going deep into the topic, I want to request you please like and share the video and please make sure that you subscribe my channel. Okay, now let's jump into the main topic. As I told, today's topic is cryogenic temperature generation. But we must know beforehand that what is cryogenics. That is, what do we mean by cryogenics? Okay, so what is cryogenics? Cryogenics is the science and technology that deals with the temperatures less than about 120 Kelvin, which is about minus 153 degrees Celsius. Okay, here I have shown a simplified diagram of comparison of cryogenic temperature with some known temperatures in the universe. Okay, comparison of cryogenic temperature on a large temperature scale. Okay, so the upper limit of this temperature scale, you may think of uh, a very large thermometer, and whose highest temperature is 10,000 Kelvin, and the lowest temperature is 0 degree Kelvin. Okay, so the surface of the sun, as we know, is very hot. So it lies in between 1000 Kelvin to 10,000 Kelvin. Okay, but this temperature is close to 10,000 Kelvin. Okay, so then we have the melting point of iron, and below 100 Kelvin, we have the temperatures like the boiling point of water, and the temperature of our human body, and the temperature which is about 0 degree Celsius. Okay, not about, is 0 degree Celsius of fresh water. Okay, pure water. And the cryogenics range, where does it begin? Here, 123 Kelvin. Okay, a little above 100 Kelvin. Okay, and here are some temperatures below that cryogenic limit. Okay, now let's see what is the next. But you must have a question that we can also achieve temperatures, very low temperatures, not very low, low temperatures using refrigerants. What is refrigerants? Like the gases we use in our refrigerators in home. Okay, okay. So you must have a question that we can achieve low temperatures using refrigerants. So why do we need cryogenics? Okay, so here we have the answer. We can achieve low temperatures using various refrigerants. Like here is the example, but then we have a limitation. We can't achieve such low temperatures, that is minus 153 degrees Celsius, which is the maximum permissible temperature in cryogenic range. Okay, we cannot achieve that much temperature using these refrigerants. So then uh, that is why we need the cryogenic technology. Then what's the way? Yes, then what's the way? Then some curious minds started searching for some solution and noticed that some gases like nitrogen, oxygen, helium, hydrogen have boiling points well below the desired 120 Kelvin level. Okay, so some scientists started searching the way and find that the boiling points of these gases is well below 120 Kelvin level. So if we want to reach that very low temperature range, we have a way that if we can liquefy these gases, okay, we can achieve those temperatures. Okay, here is a temperature chart for comparison. Okay, you can show this and may take screenshot for your uh, reference. Okay, so here is some important events in the history of cryogenics. So on the left hand side we have 19th centuries, and on the right hand side we have the events. Okay. Here I have mentioned some important events. Okay, like in 19th century we have these events which have okay, which occurred in this 19th century, and in during 20th century these events occurred. This is not much of importance. You can take screenshot and let us jump to the next slide. Okay. Okay. Now, how an object is cooled down to low temperature. Okay. How? So, to cool some object, we need some other material. Okay. What I am saying, please listen carefully. To cool some object, we need some other material that is already a bit colder. Other material which is a bit colder and absorbs the heat from the object, hence making it cold. So what do I mean by this? That if I want to lower the temperature of this object, okay, here I have written it. Sorry, not this object. This is the cooling object. Okay, let's assume uh, we have a bowl of rice. Okay, we need to we want to cool down its temperature. Okay, we want to cool down its temperature. Then what do you do? You put the relatively hot bowl of rice on a on or in a temperature, uh, on a object which has temperatures well below the object. Okay, which I mentioned here, the refrigerator. Okay, so here is the cooling object and here is the refrigerator. What does the refrigerators do? They absorb the heat from this that object, that bowl of rice, and uh, absorb absorb the temperature from that and releases the temperature to the ambient. Okay, the nature. Okay, so here I have told that this could be cold water. What? This refrigerator. This could be cold water or ice. But for really very low temperatures, okay, below that is minus 153 degrees Celsius, which is cryogenic temperature range. So we use cryoliquids such as liquid nitrogen, which has boiling point minus 196 degrees Celsius. Notice that this is well below our preferred temperature. Okay, so you will see that we will use this liquid nitrogen for our cryogenics. Okay, but you must have a question. Okay, but how these gases like nitrogen, oxygen, hydrogen are liquefied? Okay, This is the cryogenic technology. Okay. So to liquefy these gases, the cryogenic technology was developed by the scientist.